Hi everyone, and welcome back to the Cockpit build project. It's been a few weeks, quite a few weeks actually, since we last did anything on the cockpit, and the throttle has been sitting there kind of half assembled where we left it last time, and this video I'm hoping to kind of complete the throttle side of the project. And where we left it last time was we finished most of the mechanics on the throttle, and we were now turning our attention to the electronics. If you remember, we were going to use a Leo Bodnar control board, and we've already had the CNC machine drill out the mounting holes, which you can see hopefully my cursor on this picture here. And we also need some way of mounting a Hall sensor and a magnet on the axle, because we're not going to use a potentiometer. Potentiometers are okay, they do wear out, doesn't matter how good they are, they wear out after a while, whereas a Hall sensor theoretically goes forever. What we've also done on this throttle, which I didn't show last time, is I drilled a couple of holes you can see in the pillow block here, used a tap and die to thread them out, and then put a couple of hex cap head bolts into the pillow block, which act as end stops essentially on the throttle travel. So that's pretty good, and quite happy with the amount of travel I've got there. So we need to get on with the electronics now. The mounting solution. So what I was thinking is we're going to need the Hall sensor in this central part here somewhere, and we're going to have to mount a magnet onto this axle, and then as the magnet rotates with the axle, as I push the throttle forward and backwards, it gets closer and further away to the Hall sensor, which then converts that, if you like, into a resistance which the Leo Bodnar board can pick up. Now the Hall sensors I also got from Leo. They come actually with a preamp built into them. Previous experiments I've done with Hall sensors, I've had to build my own sorry, not preamp, op amp. I've had to build my own op amp into onto a circuit board, and then use that to essentially amplify the change in resistance due to the magnetic field on the Hall sensor. So yes, anyway, so we needed to make some kind of plastic bracket or some kind of bracket to hold the Hall sensor. And also we needed some standoffs as well for the circuit board, otherwise you'll end up the electronics touching that metal plate, and that would short out the board and end its life pretty quickly. So first of all, let's deal with the Hall sensor bracket, and we're going to go over to Fusion 360 and get that underway. And I'm going to go at a fair old pace here because I want to get this finished. Hopefully this video has been going on far too long, and there are far more interesting things going on with the cockpit as well that I need to show. So here we go. So over to Fusion 360, and what we need, and you'll see here that I've actually got quite a raft now of parts that I've designed for the cockpit. And for the Hall sensor, I can run through the timeline because this one's actually preserved for a change. It's unusual for my designs. So anyway, as with anything on Fusion 360, we start with a sketch. Let me just bring that up, and we can see that what we've got here is a rectangle to use as a base. I've got some rounded end rectangles which I'm going to use to mount this to the actual plate, throttle plate itself, but also give it a bit of adjustability, so we can move the Hall sensor essentially backwards and forwards, closer and further away from the axle where the magnet's going to be mounted. We also need obviously somewhere to mount the magnet itself, and because this then becomes essentially it'll be a right-angled bracket, then we probably need a piece of diagonal bracing, which is what this piece here is for. So having done this sketch, and it was fairly quick to do, we can then extrude, and we'll extrude most of the base to start with, and I think that was 5mm, and then we extruded this portion here, and apologies for it being black. Hopefully you can see that nicely. So we've got the piece here, and the top here is where the Hall sensor is going to go. So then we extruded and cut away this overhang part here. So we just extruded up again basically and cut that away. Then we needed a sketch. Now you'll see why I did this in a minute. And what we did is we did a sketch on the side of this block here, and we just did a single arc running like that, and then we use that arc to split the body, and then we delete the bit that's split above, and that gives us a nice little curve shape here running up to the top. Okay, then we did another extrude to do the spine, or the strengthener if you like, and then we did a sketch on the side of that, and I need to find it, can't see it. It would help if I make it visible. There we are. Yeah, so we did a diagonal line, and then again we split the body. Okay, so having split the body, we can delete the piece we don't want, and we end up with a nice diagonal brace between our two main right angle plates. And then it's on to another sketch, and then we did another extrude to cut away an area, and that's where the actual sensor is going to sit. And I measured the sensor obviously before I did this, so I knew it was going to fit in there. Okay, then we did another sketch, and we did two. So I get that round, even 3 U-shape channels on the face here, this face here, and if I can get Fusion 360 to orientate itself properly, there we go. Then we can extrude those through the body and cut away. Now what this will do is means that we've got the sensor head will be sat in this pocket here, and then the bare metal stalks that you would solder normally onto a PCB can protrude essentially out the back, and we can stick them between these essentially combs and keep them separated and insulated from each other. Then what we needed was another sketch down the back of the spine, and we could extrude and cut again, and we basically cut a channel down the back of the spine, and that's where, when I've soldered this to the wires going back to the control board, they can sit in that channel for cable management. And then we can extend that back along, so we did a sketch on this face here, and we can extrude cut that into that spine, and that completes our channel, so our wiring can go that way. Then we did a bit more extrusion just to tidy up the top here, and you see me cutting away a bit more at the top, and then we extruded and cut out the mounting holes so we can mount this to the plate. And that's basically our mounting solution done. We also, whilst I was at it, we needed some standoffs. So what I did is I thought I was going to do some kind of snap fit standoff, but in the end I didn't do that, but essentially made a small plate and then put some hollow hexagons in there essentially, which we can put a bolt through. These were supposed to snap, if you like, into the top of there and fit the PCB on, but in the end I didn't bother with that, just use some nuts and bolts, but still use these as spacers on the PCB, which is essentially a 2 board solution anyway. So there's a main board, and then there's the breakout board which plugs onto the top of that, a little bit like a Raspberry Pi or an Arduino, and then that goes off to the switches, but you'll see that in a minute in the photographs. Right, now obviously we weren't going to mill this out of aluminium or even plastic, and this is where I introduce a new tool essentially into the workshop, and that's a 3D printer. Now I haven't hesitated to show this previously. I don't really want this to turn into a 3D printing channel, but it's extremely useful, as you'll see, especially for custom work. And the type of printer I've gone for was just a Prusa i3 clone. I think it was even off of Amazon now. It's fairly cheap. It's made out of aluminium extrusion, which makes it more rigid than most. And to be honest, it's pretty good. And basically, we'll step over to the 3D printer now and do a bit of time lapse to show this printing out. Now all I'm using is just some black PLA filament, and we'll do a bit of talk through as that prints out in a second. So let's get over there and do these. Okay, so having finished getting the electronics, I then had to sort out a way of mounting the throttle handle to the arm. Now whilst it's a pretty good match, I did have a problem, and that was essentially as I tightened the bolts that mount the actual handle onto the arm, it was actually sliding because there's very little contact points, just the rim, if you like, of the handle onto your arm itself. It was the bolts were actually making it slide essentially off the edge of the handle, if that makes sense. So what I needed to do was add more friction actually to that, or use some kind of clamping plug on the inside of the handle so that it clamped properly when bolted down onto the arm itself. Now I figured a way to do that would be again to use the 3D printer. So here we are back in Fusion 360, and we've got the CAD for the arm that I did originally, and this shape I'm highlighting here, what I did is we did an extrude essentially of that shape, and used during the extrude, you can see that I used a taper angle of 30 degrees, so essentially as it extrudes upwards it tapers it in 30 degrees to make this kind of cone which broadly matched the inside of the throttle handle. So having done that, I actually printed this out in PLA. That was after I'd extruded the holes, so we end up with this shape here. Let me just get rid of these sketches, there you go. So we ended up with this shape here. We've got this cutout area here so that we can get the wires out down into the handle, the channel in the handle, and then the 3 bolt holes essentially. Now I just printed this in PLA, which is rigid, which isn't going to be any good for what we needed it for, but what it did allow me to do, take this using my belt sander. I then shaved down various areas of this plug until it fit flush with, or just about a millimetre proud, if you like, of the handle. And then what I did is I went back and replicated my sanding by doing, oh, there it is, don't know why it's all the way over there, but there's the sketch line there, and then I used that line to cut through and split this body, and you can see, let me just do that again so you can see what I did there. So using that sketch curve, I basically cut through to take this part away, which was the bit that needed taking off in order to make sure that this fit as level, but just 1 millimetre proud around this area of the actual handle. And the reason for that is because I then printed this out in Ninja Flex, which is a synthetic rubber filament, which then can compress when I've got the bolts in place. So we'll step over to the printer again and print this out, and then we can get the handle mounted. Okay, so we got the whole unit together now. We've got the whole sensor here on the 3D printed mount, and the magnet's just there. And what I will do is I'm going to take this axle off, drill a hole, and that magnet can seat actually in the aluminium axle. That should be fine. We've got the Leo Bodnar board in there. That's all wired up. Not the prettiest wiring I've ever done, but yeah, the loom's not too bad, I guess. We've got the friction kind of braking device, if you like, adjustable tension block there, and that's actually really good. It's really nice and smooth, the action on this. There's a couple of bits of tidy up I need to do, so I need to either hot glue the wiring into this channel which runs down the handle, or perhaps epoxy. And then we got a handle with our new analog thrusters stick there, which also has a button on there, so that's an extra button I've got. All the other controls are the same, apart from this one, which was latched previously, is now momentary, and it's got a spring return, so I can use that for tabbing on menus in Elite Dangerous. And then we've got our normal thumbstick as well, but that's now not using the original stick, it's using an Xbox controller. Things still to do on here, so I might anodise the arm in black, see how that goes. Might replace these crosshead with some nice hex socket screws. Yeah, it's quite good. Anyway, I'm going to get this over to the cockpit now, and we'll get it installed, and I'll bring you back and we'll do a flight test. So here we are replacing the old throttle with the new one, and it's all in place. We'll do the flight test, I think, on the next video. So thanks for watching, and I'll see you next time.